consider the complex geometric series, find an expression for z, the common ratio of this series. The common ratio is any term divided by the previous, and let's consider the second divided by the first. So it becomes a half e to the power of 2I theta divided by e to the power of I theta, and just applying a rule for division of powers, it becomes a half e to the power of 2I theta minus I theta, which is just I theta. So it becomes a half multiplied by e to the power of I theta. Shows that the modulus of z is less than 1. Modulus of complex number is square root of this complex number multiplied by its complex conjugate. Complex conjugate, we should change every I by negative I everywhere in expression. If complex number is given in Cartesian form x plus iy, modulus becomes square root, and actually this becomes x squared plus y squared. So it becomes square root half e to the power of I theta multiplied by half e to the power of negative I theta, which is a half and less than 1. Write down an expression for the sum to infinity of the series. Sum to infinity formula is given in a data booklet. It's the first term divided by 1 minus ratio, and hence it becomes e to the power of I theta 1 minus a half e to the power of I theta. Express your answer to part C in terms of cosine and sine. E to the power of I theta is cosine theta plus I sine theta. This formula is given in a data booklet, hence our sum to infinity becomes cosine theta plus I sine theta over 1 minus a half cosine theta minus a half I sine theta, and hence shows that cosine plus a half cosine up to theta and so on up to infinity and is equal to this expression. And here we can see that the left hand side is the sum to infinity, but since there are only cosines, and if we consider this series, we can see that each term, for example this one, it's a cosine plus I sine, this is a half cosine of 2 theta plus I sine of 2 theta, and since there are only cosines, we can conclude that we should consider only real parts. So we need consider the real part of the left hand side of this series, and since we know its sum, it's this expression or this expression, so we should equate it to the real part of this. So we should do the next. We should consider real part and equating the real parts. So real part of e to the power of I theta plus a half e to the power of 2 I theta plus so on is equal to the real part of cosine theta plus I sine theta 1 minus a half cosine minus half I sine theta. And definitely the left hand side is cosine theta plus a half cosine of 2 theta and plus so on, and we need find the real part of the right hand side, and we can conclude what is the real part, what is the imaginary part, only if this expression is of the form something without I plus I multiplied by something, and hence its real part, its imaginary part. So we need to get rid of I in denominator, and to do that we multiply numerator and denominator by, so let's consider 1 minus a half cosine in parentheses minus I a half sine, and so that to get rid of this I we multiply, so that we get formula a minus b, a plus b, and so that it will be a squared minus b squared. So we multiply by 1 minus a half cosine plus I a half sine theta, and here 1 minus a half cosine plus I a half sine, and hence denominator becomes 1 minus a half cosine squared minus this squared, but I squared is -1, so it will be plus sine squared over 4. And what about the numerator? And actually we need only the real part, and we can see that it becomes cosine multiplied by I, or actually let's consider a real part of the right hand side to not rewrite it again. So hence the real part of the right hand side becomes 1 minus a half cosine theta squared plus sine squared theta over 4, and in the numerator we need only terms without I, so we can get terms without I when we open parentheses only when cosine is multiplied by 1 minus cosine over 2, and when I sine is multiplied by I sine over 2, so it becomes I squared -1, so it will be minus sine squared theta over 2. And actually what we need on the left hand side, it's directly this, so we need to show that this is this 4 cosine minus 2, 5 minus 4 cosine, so we need to simplify it, so it becomes cosine minus cosine squared theta over 2 minus sine squared theta over 2, and in the denominator 1 minus 2 times 1 times a half, so it's minus cosine plus cosine squared over 4 plus sine squared over 4, and we can see that it's minus a half because sine squared plus cosine squared it's 1, so it becomes cosine theta minus a half And also we can see that if we factor out 1 over 4, it becomes also multiplied by cosine squared plus sine squared, which is 1, so plus 1 over 4. And let multiply each term by 4, and it becomes 4 cosine minus 2, and 4 minus 4 cosine plus 1, which is 4 cosine minus 2, 5 minus 4 cosine theta, and let's check 4 cosine minus 2, 5 minus 4, yes, as required. So we can see that cosine theta, yes, cosine plus a half cosine of 2 theta is equal to this value as required. So we can write it, therefore cosine theta plus a half cosine of 2 theta plus so on is equal to 4 cosine theta minus 2, 5 minus 4 cosine theta. As required. And that's all for this question.